Welcome to Section 6.3, Part 3, Solving Systems Using Elimination. As a warm-up, I want you to try solving the system using elimination. Again, remember our steps. Step 1, make sure they're in standard form. They are. Step 2, look for the variable that has the same coefficient. In this case, neither of them do, so we have to make them have the same coefficient. We're going to multiply the top equation by 2, the bottom equation by 3. Top equation becomes 8x plus 6y equals negative 38. Bottom equation becomes 9x minus 6y equals negative 30. Add the two equations together to get 17x equals negative 68. Divide both sides by 17 to get x equals negative 4. Now that we know x, we go back to solve for y. So 3 times the negative 4 minus 2y equals negative 10. Negative 12 minus 2y equals negative 10. Add 12 to both sides. Negative 2y equals 2. Divide both sides by negative 2 to get y equals a negative 1. My solution is negative 4, negative 1. Let's review our possible solutions for systems. Remember, we can have one solution, no solution, or an infinite number of solutions. Remember what one solution looked like in a graph. It had one intersection point. Remember how it looked when we solved equations using substitution. We solved the system and we were left with x equals the number or y equals the number. Zero solutions on a graph were parallel lines. They had no crossing points. In an equation, when we solved the system, we're left with a false statement like 8 equals 2. Infinite solutions have an infinite number of crossing points. The lines actually overlap. How does this look in an equation? Well, when we solve the system, we have a true statement like 2 equals 2. Let's take a look at an example. We're going to follow our same 5 steps that we've been using for the last 2 sessions. We're going to first make sure our equations are in standard form. They are. We're going to then try and find the variable has the same coefficient. In this case, neither one has the same coefficient, so we have to force one of the equations to have the same coefficient as the other. So in this case, I'm going to multiply the bottom equation by a negative 2, so that my top equation and my bottom equation, the x's have the same coefficient but opposite signs. So I have 2x plus 6y equals 18, negative 2x minus 6y equals negative 18. The two x's cancel out, leaving me with 0 equals 0, which is true, so therefore there's an infinite number of solutions. Take a look at this one. We check for standard form. It's in standard form. We look to see if there's any equations that have the same coefficients. There are, both x and y in this case. So we go ahead and subtract our equations, or we multiply through by a negative 1 on the bottom and add them to get 0 equals negative 5. That's false, so therefore we have no solution. One solution would look like our warm-up problem and the problems that we did in sessions 1 and 2. Your homework for this part of this section is page 378, numbers 21 to 26.